Good evening. I'm Eric Isaacs, president of Carnegie Institution for Science, and I'm really delighted to welcome you here to our Capital Science Evening at the Martin Luther King Jr. Memorial Library in downtown DC. I'm also delighted to welcome our guests who are virtually tuning in tonight. I'm sure we're in for a really big treat tonight. I'm really delighted to welcome our speaker, Professor Marshall Shepard. He's a renowned meteorologist and a climate science expert. And what he does is he brings a deep understanding of both climate and weather, but the inextricable link between climate and today's societal challenges, which is, I think, what we're going to hear a lot about tonight. I'm very excited about that. He is a distinguished professor of geography and atmospheric sciences at the University of Georgia and former president of the American Meteorological Society and host of, I love this, Weather Geeks podcast, which is great. And he will talk about really what a warming world means for all of us, but also for particular communities throughout the US and around the world. He's an expert in these interdependencies that put communities at risk due to things like climate change. I think he'll also explain to us the differences between weather and climate, because I think sometimes we forget what that is. He gave me a great description before, but I'll let you do it. But in particular, one of the things he does, which is he's a great communicator, and he studies this, how the public receives this information of climate change. And so, of course, very relevant today. It's about climate, but it's also about how we receive science and facts in today's society. So it's a really interesting and very lively area of research. Tonight, he's going to talk about some of the contemporary societal challenges that intersect with these two things, weather and climate, as well as how these types of inextricable links relate to decision-making, to politics, to communications, and how he incorporates his own scholarship into thinking about these problems and hopefully advancing this as we proceed. He's a frequent sought-after expert, and just to give you an example, his research has informed key leaders in the White House. He's had lots of work with the White House, with Congress, with NASA, and the Department of Defense. A little bit of history. Prior to beginning his tenure at Georgia, Dr. Shepard was 12 years at NASA as a Goddard Space Flight Center just outside of DC here. And he was a project scientist for the agency's Global Precipitation Management Mission, which he launched in 2014. He is a member of the National Academy of Sciences, the National Academy of Engineering, and the American Academy of Arts and Sciences, a triple threat. His work has been recognized by many awards. I'm not going to go through all of them because I don't want to embarrass him, but I have to mention a few because we're proud to have him here tonight, including the American Meteorological Society's Brooks Award, the Helmut Landsberg Award for pioneering significant work in urban climate, the AGU, the American Geophysical Union's Climate Communications Prize, and the American Association for Advancement of Science's Mani L. Baumek Award for public engagement with science. He's currently serves on the National Academy of Sciences Board of Atmospheric Sciences and Climate, as well as a Space Studies Board, so kept busy here in DC, apparently. He received his bachelor's and master's and doctorate all in physical meteorology, all from the Florida State University. He was the first African-American to receive a PhD from Florida State University Department of Meteorology, and which is one of the nation's oldest and most respected programs in that area. So I'm very excited to hear what Dr. Shepard has to say tonight, and I will welcome him now up. Please join me in giving him a welcome.
Thank you. So thank you for coming out. I'm going to stand here at this podium, so get your shots now because I won't be here long because I like to move around when I talk. But it's really an honor to be here, and I want to thank everyone for the invitation to speak to you tonight. I was reflecting with a friend of mine, Dr. Dan Krieger, who's somewhere, there he is. I used to come to DC quite often, but since COVID, I think this is my first trip up to DC because many of those boards that I'm on, they're by Zoom. And at first I thought this is great, Zoom, because I actually don't like to travel and fly too much, but I tell you, the Zoom fatigue has certainly set in over the years. I'm pretty sure by the nods that many of you agree with me. So it's really great to see you in person. And so I hope to engage you, provoke you, make you think. But before I do that, I am actually the rare speaker that I don't mind if your phones are out. Feel free to tweet post on social media anything that you hear that you want others to hear, because I know that we have, I was told there may be up to 500 people on Zoom listening in, and I was a couple of hundred registered for in person. And I don't like for my scholarship and my talks to stay in our little ivory tower bubbles or I want them to get out. So I'm at Dr. Shepherd 2013. If you don't follow me, please do, because I want that to be tweeted. And I see my good friend and colleague Allison here, and I know she's going to be tweeting. So, so let's get into it. Let's just get into it. So what is this madness, this cloudy with a chance of science that you're talking about? Shaping a discussion at the intersection of wicked problems in society. A little story about how this talk evolved. The president of my university came up to me one day and said, Marshall, the accrediting agency, SAC, for our university has a keynote speaker, and they want you to speak to them. I was like, why would I speak to a bunch of college university accreditors? And they said, well, they want you. They saw one of your TED Talks, and can you just come up with something that really intersects with your science, but is accessible to the public? And so I started thinking about this notion of wicked problems in society. And I operate within the framework of weather and climate. And weather and climate certainly touches aspects of society, but also has wicked challenges. So a little history, we have to start off with sort of this notion of history. So we've got to go back to 1973 with design theorists Riddle and Weber. They introduced this concept of wicked problems, and they introduced it to draw attention to the complexities associated with planning and social policy problems. And as I think about the world that we live in today, I think there are several wicked problems that have confronted us. There's one. I mean, it's like you say Madonna and everyone knows who Madonna is. I put that up and you know immediately what that is. COVID, coronavirus, fundamentally changed our lives. It was a wicked problem on several fronts that we're still dealing with today. I mean, you can see evidence in this room of that. COVID. There's my home state. I live in the state of Georgia. And while this doesn't jump out at you the way COVID does, this is showing you wind gust in the southern part of Georgia from Hurricane Michael in 2018. That area of red represents 70 to 100 mile per hour winds far inland into Georgia. It destroyed our peanut, pecan, cotton, and many other crops, much of which Georgia leads the nation in. So if you're paying more for Jiffy peanut butter or cotton t-shirts, probably because of Hurricane Michael in 2018. A wicked problem. George Floyd. The tensions around race and culture in this country, the ultimate wicked problem. And I don't shy away from it because I'm an African-American scientist in my field of meteorology. I'm the former president of the American Meteorological Society. I know the numbers, only 2% of my field is African-American, 1% Hispanic. And so when we think about some of these interconnected problems, many of these weather climate issues that I deal with disproportionately affect communities that look like the one that I grew up in Canton, Georgia. A wicked problem. And then there's this, and hopefully we can get it to start. I don't know if you have to click it again or if you all can start it from up there. This is supposed to be animated, but as we get this to go, we start in the late 1800s. We are looking at the temperature anomalies, the differences from normal. And as this moves forward in time, it will clearly show us that global warming is occurring. Now, one of the questions that I often get in certain audiences is, well, you guys tried to sneak in a name change. Why do you call it climate change now and not global warming? Well, Global warming is just a symptom of climate change in the same way that a fever is a symptom of the flu or COVID. It's just one aspect of the way our climate is changing. So hopefully you can see, as this NASA animation is progressing up to current times, the expansion of warming that has occurred. And I deliberately put this in Fahrenheit because we're in the United States, we speak Fahrenheit. And that's important because you often hear the Paris Agreement and all these discussions about climate policy in terms of 1.5 degrees C. We don't speak C here in this country. So I like to put these things in terms of Fahrenheit. So that's just a stunning visual to me of one of the grandest wicked challenges facing us all. That's a wicked challenge getting through that intersection. But many wicked challenges sit at the intersection of science, perception, and society. And so that's the journey I want to go on tonight as we think about some of these challenges. Again, I'm a meteorologist, so I'm going to anchor much of this discussion in weather and climate. So let's start with the year 2022. Anyone remember what happened in Southwest Florida during hurricane season last year? Hurricane Ian made landfall and unfortunately was quite the disturbing event. Now, one of the big challenges is that many people perceive that was a bad forecast because the cone of uncertainty, which you see there, was moving around some in the days prior to landfall. But look at this. This was the forecast for Hurricane Ian about 5 days in advance. Where's that cone at the end of that period? It's right near Fort Myers where it actually made landfall. Now, in true candor, it did eventually evolve and move up towards Tampa. And that created a challenge because many people perceive that this cone suggests that the hurricane is going down the center of that cone. But in fact, this cone is telling us that there is a 2 out of 3 chance that the center of that hurricane could be anywhere in that cone. But it's one of the challenges we have with conveying probability. So even when the line, if you will, that center line was up near Tampa a couple of days before landfall, the ultimate region that was the landfall was still within the cone. And so it exhibits one of the challenges, just like if I told you there is a 10% chance of rain tomorrow here in Washington, D.C., many of you or many of the public may perceive that, oh, it's not going to rain. Right? 10% chance. It doesn't sound like a lot. But as a guest recently on my podcast, Weather Geek said, if I told you that someone you know had a 10% chance of getting in a car accident when they're leaving tonight, doesn't that feel a little bit more sort of risky? 10%, right? So our perception of 10% varies, right? And so one of the things we know is that there's a challenge with communicating uncertainty. This is something that I like to show. It's from the American Association of Advancement of Science. If you see blue, that's the difference between what scientists in that given field think about a topic versus the public from a survey that AAAS did. So essentially what this shows us is that there somehow now is a disconnect at times between public perception of science topics and what the actual scientists that study it believe or know about it. How do we get there? And if anyone has the answer to that question, I'd love to talk to you after, because that's a wicked challenge in itself. But how did we get there? Well, I posit, and if you've seen my TED Talk, I'm borrowing some concepts from that talk. I posit that what shapes an individual and institutional perception about science can be described in very simple terms: shapes. I'm going back to the fundamentals of what I learned when I was 5 to talk about some complex challenges in society. Circles, triangles, and boxes and squares. first point that I want to make is being boxed in, stuck in the boundaries created by our marinades. What do you mean, marinades? Well, if we marinate some vegetables or meat, it takes on the flavor of the marinade. Many of us are shaped by our cultural, geographical, political, religious, and other marinades, and it shapes our views on science. And so we have to understand how our personal marinades shape us. So let me reflect a little bit on my marinade. And it starts with a honeybee. I don't know, what's your name again? Jalea earlier, as we were sitting here chatting, asked me, how did I really get into meteorology? And I shared that it started in 5th grade. I was that kid in the yard catching honeybees and ants in jars and watching them for hours. Except I got stung by a honeybee and almost died because I found out I was highly allergic to bee stings. And this was before the days of carrying EpiPens around. And so my 6th grade science project was coming up, and I said, I need a plan B, pun intended, because I can't do a science project on something that could kill me. And so I switched to weather. I made weather instruments from things around the house. Science project was called Can a 6th Grader Predict the Weather? And I won the science fair and went on to the district and won that. And at that point, I knew I wanted to study weather. I never wanted to be a forecaster. I didn't want to be on, I guess, you know, the folks up here, what, Bob Ryan and Doug Hill and all those folks from way back in the day, all good friends and colleagues of mine. I didn't want to do that. I was more interested in the hows and whys. So I went on to Florida State, really good meteorology program, got my degrees there, and ended up working at NASA Goddard Space Flight Center right out here on the Beltway in Greenbelt before going back to the University of Georgia as a faculty member. So with that marinade, let's go back to people's perceptions. There's a groundhog and a farmer's almanac. They both shape people's perceptions about weather. They really do. People think the farmer's almanac's accurate. I get people that come up to me and say, well, you know, Dr. Shepard, that climate change stuff is bunk. Oh, but what do you think of the groundhog's forecast? So I think it's a rodent. I mean, there's studies that sort of, now I don't want to completely dismiss the farmer's almanac. It's a climatological tool. It's about 37% accurate on a climatological scale, but the complexity of weather, we've kind of figured it out within 0 to 10 days using complex geophysical fluid dynamics models and so forth. So we actually use complex models and physics and calculus to predict the weather today. We're not sticking our finger at like this, but there's some people that believe that though. All right. Oh, it's covering it. The caption is covering that, unfortunately. But what that said, oh, thank you. Ask and you shall receive. Heat lightning is not a thing. That's another perception challenge because many of us have grown up saying, oh, you see that lightning flashing off in the distance? It's caused by the heat of the day. No, it's just a storm too far away to hear the thunder. What I'm trying to set up for you is that your grandma or your uncle probably told you that and you believed it, right? My mom used to tell me if I swallowed a watermelon seed, a watermelon would grow in my stomach. I mean, because that's just a marinade of culture. You're shaking your head, you've heard that. So our perceptions and our marinade shape. All right, the next thing that really shapes how we think about science and some of the wicked challenges is belief systems and biases. There are 3 questions that I get as a meteorologist. The first is, what's the weather going to be tomorrow? All right, and I just told you I don't actually do forecasting. The other question is, what channel am I on? Because most people think that all meteorologists are TV meteorologists when only about 8% of our field are TV meteorologists. The third question that I often get is, you know, my daughter's getting married next September. It's an outdoor wedding. Is the reception going to have rain? But this is the fourth one that has crept its way into that trio, and now it's the fourth. Do you believe in climate change? Now think about that question. Do you believe in climate change? Climate's not a it's not a belief system, right? If we throw a ball off of this building, I don't believe that it's going to fall. It is going to fall. Gravity is a thing. So that question's always ill-posed to me. So again, a ball falling off of that building there in Atlanta, it's going to fall because gravity is a thing. Now, this is a look at the Yale Climate Communications annual survey results of America. It's called the Six Americas Study. Yale does this every year. My good friends, Ed Maybach and folks up there, Ed's actually at George Mason, and Tony Lucero, which is at Yale. I was trying to think of his name. They find every year that America breaks out into 6 distinct groups on climate. And you can see them. This is the results of 2021, but you can go on their website. They have 2022, 2023. I want to point out to you that last group, that 9% group. That's called the 9% dismissive. That is the group that's the loudest on Twitter. That's that uncle at Thanksgiving dinner that has YouTubed something. I'm totally on YouTube, but I'm totally in the scientific literature as well. And so we have to understand that the 9% dismissive, you're going to waste your time if you're trying to convince that group. You can spend time with the disengaged and the doubtful, because certainly there are people that have uncertainty and fair questions. But understanding this 9% dismissive is very instructive when you try to understand how to deal with the discourse on climate change. Here are some things that we often see as climate scientists, or even as meteorologists: confirmation bias, consuming information or anchoring to things we already believe. See it all the time. Dunning-Kruger effect. By show of hands, who's familiar with the Dunning-Kruger effect? A couple of hands went up. Most hands did not go up. But when I tell you what it is, you're going to say, oh, I know what that is. I know someone that does that all of the time. So Dunning-Kruger effect, these 2 Cornell psychologists published a paper sort of noting this sort of tendency for people to underestimate what they don't know and inflate, the things that they think they know. So now you're shaking your head like, oh yeah, I know people that do that. And so we see that quite a bit. Motivated reasoning, that comes back down the lane of the hurricane. One of the big challenges that we have is oftentimes when there's a Cat 5 hurricane approaching land, there are many people that won't leave. Or there are people that will drive through a flooded roadway, even though they know that there's a chance of the car being washed away because they got to get their kid at daycare. So there's motivated reasoning that justifies decisions, even though those decisions aren't necessarily anchored in sound reasoning. And then what I call the trio biases: normalcy bias, optimism bias, and recency bias. Normalcy bias is, again, related to what I just talked about hurricanes. Well, it always rains in Houston. What's the big deal with Hurricane Harvey? Right? Harvey produced 50+ inches of rainfall in 1 week. That's not normal. But the reason I emphasize that is people shape their decision-making and policy based on reference points or context that they experience. But the challenge is we are experiencing new normals. So our database of what's normal needs to shift, because if you're making decisions based on Hurricane Harvey or even Katrina, there's something coming that's likely going to be worse than both of those because of the attribution of climate change. Optimism bias, this notion that I live in a flood zone and I know it, but I'm not going to buy flood insurance. There was a statistic that came from the federal government that showed how many homes did not have flood insurance in Florida last year after Hurricane Ian. So that's an optimism bias because I live in a flood zone, but I'm not going to buy flood insurance. But I think I'll go buy a lottery ticket for Powerball tonight. Think about that. Optimism bias. And then recency bias, this notion that we sort of look at things in recent terms without context. So perception and misinformation is a challenge, and partly because of social media. During Hurricane Irma a few years ago, I remember BuzzFeed actually assigned this journalist, and her sole job that day was to keep track of all the misinformation that was out there on the forecast. Because you had all kinds of people tweeting and putting out information that wasn't from the National Hurricane Center or from authorities like the Capital Weather Gang. By the way, Steve Trachten's here in the audience. He's a colleague that I know many of you may listen to or read the Capital Weather Gang, a credible source here. That's a source I would go if I lived here in the area. So, and then this is one of my favorite, this poor physicist, all that work, and then some guy on Twitter says you're wrong. So these are the types of, again, I'm having a little fun with this, but I hope you get the root point that I am making, right? That's Houston, Texas in the days after Hurricane Harvey. And I made that point earlier because I talked to someone and I talked about this normalcy bias. I talked to a friend and it was like, we get flooding here in Houston all the time. We didn't think it was going to be that bad. And that was because their context or their anchor point was rooted in their perception of normalcy. All right, so we've walked through two things that shape perspectives on science, and ultimately these things shape how we make decisions. The third thing, literacy and mental models. Literacy and mental models. An observation that I have made being a professor at the University of Georgia for over 17 years, and also just being a public scholar that engages with people ranging from the president at the White House to just someone eating at the Waffle House. Through all of those experiences, these are some things that I have observed. People struggle with probability and uncertainty. I've already talked about that when I talked about percent chance of rain. Tell you another story. I'm probably gonna go over my time. I gotta tell the story. I was actually tubing down the Chattahoochee River in the North Georgia mountains with my son. This was several years ago. He's little. We were in one of these little inner tubes just floating down the river, and it starts raining. This woman next to me in a tube did not have any idea what my profession was, but said, see, those meteorologists are always wrong. There was a 20% chance of rain, and here it is raining. And I was thinking to myself, it wasn't 0%. But that perception exists. By the way, I'm not going to quiz you, but who in here is confident by show of hand, you know what 20% chance of rain means? Look at all the hands sitting on those hands. Yeah, it's really an interesting concept that takes into account sort of aerial coverage and confidence of the forecaster. You get all kinds of answers to that question. So back to my discussion. People struggle with probability and uncertainty. People also struggle with things that have multiple processes involved and concepts that cannot be simplified to their mental models of understanding. I see this all the time in my classrooms at the University of Georgia. And these kids are coming into UGA as the 15th ranked public institution in the nation. Kids with 4.2 GPA. I don't even know how you have over a 4.0 these days, but they do. If my daughter's in there, they got these ridiculous SATs and so, but they struggle with a concept that involves two things happening at the same time, or three things happening. So I'll give you an example. When a cloud forms, there's a parcel of air that's rising. It has moisture in it. As that parcel is rising, it's cooling. And as it cools, that parcel expands through adiabatic cooling. That's a multiple process, and they struggle with that. And so I have found that people in general tend to struggle with those concepts. Yet many of these wicked challenges that we have talked about are multivariate. They have multiple variables, or they have multiple outcomes. And so this is something that I've observed. And so here is my percent chance of rain discussion. This is just the sort of, I saw this is a good way of sort of, since I brought it up, this is a good way for you to at least think about it. Just keep in mind that 10% or 20% chance of rain doesn't mean it's not going to rain. The other thing that I'll share, since again, we're on the topic, when you pull out your apps, which is what most people look at these days, those apps have information, but oftentimes it's static. It tells you something at a given time, but weather evolves throughout the day. So be sure to understand the evolution of weather and how it is impacting your location. Okay, with that multiple process framing in mind, let's go down the road of climate again. Here is a look at carbon dioxide values over the last 800,000 years. Well, how do we get those? Well, we use things like paleoclimatological records, ice cores, and those types of things with trap bubbles inside. We could use isotopic analysis. One of the things you see is something that people tell me all the time, Dr. Shepard, the climate changes naturally. And we can see that. You see the sort of oscillation or that's indicative of our ice ages. They're clearly evident. But just because we have a naturally varying process does not mean human influence on top of it can't be a problem. Grass grows naturally, but when we fertilize our lawns, it grows differently. A good baseball player can hit a home run naturally, but in the era of performance-enhancing drugs, there were longer and more home runs. So I'm trying to dispel this notion that a natural process cannot have an anthropogenic influence on top of it. Now, look at that last dot. That's our current, as of 2021, parts per million CO2. So it is well outside of that sort of natural boundary, right? So I write for Forbes. I'm a senior contributor to Forbes. I wrote an article one time saying, what's your carbon dioxide date? We have a birth date. What was the carbon dioxide ppm amount when you were born? And compare it to today. So if we could slide that box away for a moment so that we can, I set the context up with shapes. I've talked about boxes. I spoke about being boxed in, but I think the solution to help us to move forward with engagement, decision-making, and policy on science involves circles. Where are you going with that? Well, got to bring in a little math. So if you hate math, just look away for about 2 seconds. The radius of a circle, to get the area of a circle, it's pi r squared. So how do we make a circle larger? Not a trick question. Increase the radius. So in order to expand consuming and understanding of science, we have to expand people's radiuses or radii. That's me standing in the University of Georgia's football stadium during the last eclipse. We decided to expand people's radius, taking advantage of that eclipse. I'm on the athletic board at the University of Georgia, 2-time national champions, by the way, football. I had to slip that in. We saw a teachable moment. So we went to the athletic department and said, we'd like to host the world's largest eclipse classroom in UGA's football stadium. They agreed. We put it together. We bought 50,000 sunglasses for the eclipse. We advertised it to the public during a school day. Classrooms, the public came from everywhere. And we taught that day. until we actually reached the point where the eclipses come. So that was an opportunity to expand radius. So what are some strategies to expand radius? Take an inventory of our own biases and marinades. I want everyone to think about this. What shapes how you view science, science policy, and decisions? Take an inventory of your own biases and marinades. Ask why they exist. Then if you find that there may be some problems with it, and I think we all have biases, right? I think we do. And develop an action plan. Evaluate where you consume your information from. And then speak out on how you actually expanded your own radius. And these are just solutions that I see. So as I start to draw to a close, you know, some weird alignment, speaking of celestial happenings, happened for me personally in 2021. I was elected to 3 national academies. If you don't know what that means, and I, frankly, some of my own family didn't, it's kind of like the Grammy Awards of being an academic, right? And I put this citation from my National Academy of Engineering induction on the screen, not to sort of brag about or anything. I want to make a point about it. It said, for the development of methods to understand the Earth's hydrometeorological and hydroclimate system. That's my science. That's what I do. Got a lot of publications and a lot of grant money and those types of things. But then something that you don't often see, it said, and for climate science, public communication, and outreach. I thought that was a watershed moment, because people that do what I do back in the day, whatever that means, were criticized as popularizers, not serious scientists. But now I tend to lead my department every year in peer-reviewed publications and grant money, but I still tweet. So you can do these things. They're not mutually exclusive, right? We need a new era of what I call end-to-end scholars. And so this is a challenge to some of the younger people in the room and some of the older people in the room. We have to have end-to-end scholarship. We cannot get on and stay on the academic treadmill of just being in classrooms, going to conferences, and publishing in scientific journals. We have to do those too, but we also have to engage broadly. You see a picture of me testifying before the House Science Committee in 2019. You see a picture of me with Louis Uccellini, the former director of the National Weather Service, on my TV show, Weather Geeks, on the Weather Channel. We have to engage and be end-to-end scholars. So since we've talked about shapes, we got to bring in triangles. We got to show triangles some love. This is a graphic from the American Association for Advancement of Science, AAAS. And it sort of brings home the point that I'm making about end-to-end scholarship. How many of you, by show of hands, has a graduate degree of some type? Most of you in this room, I assumed as much. When we were taught to do our master's theses or our PhD dissertations and so forth, we're taught this triangle. Give all the background, supporting details, and then 300 pages later, we tell you what we found. That's just how we do it. But when we're talking to Congress or the public or the media, you got to get the bottom line right up front. You've got to invert that triangle. The average congressman or television story doesn't care about the Monte Carlo method that you use to arrive at that result. So you've got to be dexterous enough to communicate in both circles. And I want to invite you to take a look at an article I wrote in Forbes about 5 years ago called 9 Tips for Communicating Science to Non-Scientists. And I talk about strategies, including this one. So I want to end on a high note. And I think I've not been doomy and gloomy, because I don't like to take that type of approach. Most Americans support a role for the United States as a global leader in science, according to research from Pew. So though we have seen this sort of period of denial when it comes to climate change and vaccines, and at times you start to say, wow, where is science in this discussion? How do people perceive it? There's still a belief that science is a value in our society. Every aspect of our being today required some type of STEM, science, technology, engineering, or math. From the cell phone in your pocket, the transit system that you use to get here, to the medicine you may be taking, to the weather forecast of this almost 90 degrees here in DC today. I wasn't going to let that slide because I just came from Atlanta, Georgia, where it was in the upper 70s. It's early April. And I took a peek at the models. One model was suggesting the possibility of a hurricane spinning up, or a tropical system spinning up in the Gulf of Mexico last week. I think that's fizzled now. It's April. So hopefully through the course of this, however long it took me, I made you think a little bit about shapes, but also made you think a little bit more about the implications of those shapes and how we perceive science. Thank you so much. Thank you. And from what they tell me, I think we are now going to have a question and answer period.
Everyone knows about it. Well, that was terrific. I mean, that was a great talk and made me think a lot. So I want to come to your last point first, which is about every scientist is sort of a soldier in the battle to teach people. And I was today in a senatorial office, I won't say who it was, and they said exactly the same thing to me. They said, you don't come and tell me about calculus and those things. We were trying to sell a very big telescope, the extremely large telescope.
Sure.
Same story. But let me come back to who's actually responsible. I agree, every scientist ought to learn to tell a story, and then it ought to start with a miracle happens, but this is how we get to the miracle, right? Miracle will cure the earth of climate change problems, but here's how we're going to do it. And this relates to a question we got about meteorologists. Sure. So you being meteorologists have access that most people don't have. They're on TV. Well, 8% are on TV, but the rest are writing and, for magazines, et cetera. What role do you think the meteorologists have in helping people understand climate change? You're talking about the weather tomorrow, 10% rain, 20% rain, but you did a very nice job in talking about the difference between climate change and weather. Do you think meteorologists, given their presence, a lot of people respect meteorologists, what should be the role?
So if you're talking about TV meteorologists, then they absolutely have a role, because think about it. Who is the scientist that most people see every day? A television meteorologist. And most meteorologists do have a degree in meteorology. All don't, but so the American Meteorological Society, which I did preside over in 2013, we stood up a program called the Station Scientist Program, because many people that flip on, and honestly, be candid, most people don't watch local news anymore, not in the same way that when I was a kid, when everyone flipped on the local news or even the nightly national news. But there are certainly some people that do watch it. And so we realized that. And so we stood up something called the Station Scientist Program to help enable TV meteorologists with tools to help to convey information on broader topics, things like tsunamis and meteors. People ask us a lot about meteors because we have meteorologists in the title, but we don't study meteors. I actually got an email. No, I'm serious. I got an email actually just before I came up here. Someone was asking about a meteor and so forth, but we can talk about them because we generally are. But it's just one of the realities of what we, again, perception, right? Another really good organization that's out there is an organization called Climate Central. They're based out of Princeton, New Jersey. They're an organization that produces climate-ready stories that TV meteorologists can integrate into their weathercast every evening. And I think that's been very important for conveying this information. There's a climate story that can be told every day on the news, not just from a weather climate perspective.
So related to that, and this is also related to one of the questions from a teacher who
Mhm.
deals with students every day. You know, if a meteorologist predicts it's going to rain tomorrow, people say, okay, I'll bring my umbrella, you know,
Mhm.
be a little anxiety. But when you talk about climate change, there's huge anxiety.
Sure.
And so this question is really about how a teacher might talk to their students to talk them through, not just get them off the ledge and anxiety, but how do you talk them through this kind of, you know, this sort of existential, potentially existential threat that we're now seeing? How do you talk to people about that?
It's a delicate balance because I actually don't like to take the doom and gloom approach. I like to be realistic about the threat and the risk involved, and they're significant. It's a climate crisis for sure. But I think there actually is research that suggests that some people can be turned off by the helplessness associated with this idea of a bigger problem that we can't do anything about. So I think the approach for the K through 12 community, that which I assume this teacher is from, is that we have to talk realistically about the science and what's happening so the kids are able to understand the science, but also optimistically talk about that we know what to do. Mitigation, reducing emissions, adaptation, in some cases, we just have to adjust. And so it's an opportunity to talk to kids about technology, about engineering, about things that we can do on those mitigation and adaptation sides of the house. There are things that all of us can do individually, right? I mean, composting or eating less red meat. These are solutions that reduce carbon emissions. But I am realistic; those aren't going to get us out of the problem. Those are incremental. We still are going to need transformational solutions.
One more question along this line, which is, I'm not sure if this is tongue in cheek or not, actually, but it's a good one. You know, your work touches a lot of areas, but in particular, this sort of interface of good information with skepticism, and you talked quite a bit about that. And so the question is this, is, you know, how do you even handle it? Because there's a hostility out there, right? It's become very political. You talked about marinating, I think was the word you used, but I think it's even beyond marinating. I mean, I think people are out there fighting a battle to win this. It seems to be beyond that. So how do you think about that skepticism, and what do you do to?
Well, again, the point I was trying to make is I actually, and I'm in these hallways and circles like you as well. And I'm in a state that many people would consider purplish. But we're leading in solar and EV production now in terms of batteries and cars. So what I say is there's a lot more noise than signal in some of those circles. And so I try not to get too bogged down with the noise and try to focus more on the signal that's there. And so I think there is movement. I mean, even here in Washington, with some of the recent bipartisan legislation that's passed, there are some good things in there concerning science and climate change. I am certainly hoping. I didn't drive my EV up here, but I would have if there had been more fast chargers along the route. But I think some new legislation is proposing fast chargers every 50 miles along interstates. That's a solution. That's progress. And that had bipartisanship. So again, what my experience was, and when I showed you that picture of me testifying for the House Science Committee in front of both sides of the aisle, by the way, I don't know, for those of you that watch these hearings, it's a couple of hours of good discourse and grilling, but I did not find any unreasonable discourse from either side of the aisle in that particular hearing. So I am seeing a slow turning of the boat, if you will. Now, you just got to be very careful about it, because even in our state, you might not hear certain words being used, but you look at some of the things that are being done and you're like, oh, okay.
So let me move a little to the science, and then we'll come back to the sort of the humanistic impact of climate change. So the first is from a purely scientific point of view, do you see advances being made in modeling climate? I mean, modeling climate, modeling weather, which is also a model, and the link, this inextricable link between the two of them.
Yeah, I do. I mean, one of the big sort of, I guess, skeptic arguments, so what I call zombie theories. What's the zombie theory? It's a theory that lives on out there like zombies, even though science has long put to bed that what people are saying about it. So one of the zombie theories that was out there for a long time is, oh, you can't trust the climate models. They don't know what they're doing.
Yeah.
But a lot of that narrative comes from these premature, immature models that were really just atmosphere models, maybe a model coupled to an ocean system. These days, our climate models are full Earth system models. that are representing the biosphere, the cryosphere, where the ice is, and so forth. And they're actually pretty good. And we know that because there are sort of hindcast, if you will, experiments where we sort of run past models forwards today's climate, and they do a pretty good job of replicating what our climate looks like today. On the weather side, we've made significant strides. The models now, again, there is a limit, and I don't think a lot of people understand this. There's a sort of a predictability limit of about 10 to 14 days with the weather models. The weather models are solving these Navier-Stokes equations, these fluid dynamics equations. It's an initial value problem for those of you that took calculus back in the day, based on initial conditions. But we're getting better with information going into the models because of all the satellite and other observations that we can assimilate or feed into the models. One of the big drivers of its skill in weather forecasting is just the power of the computer itself, because we can get finer resolution models.
So, I mean, coming back to that sort of the physics of this, so I'm a physicist, we understand the temperature, global temperature, average temperature, as it's basically a simple physics problem.
It is.
How much light gets in, how much gets reflected, how much gets radiated. It's kind of about it.
Global energy.
So that's global,
Yep.
right? But if you ask a farmer in Illinois, are you going to get rain? Is your farmer's almanac? How do you make those ends meet? Are we getting closer to be able to predict? Essentially, what I'm saying is, climate, but how that impacts weather on a local basis, so that somebody like a farmer could.
Sure. So I was a co-author on a National Academies report in 2016 on a part of our science called attribution. This idea that we now have the skill to attribute certain extreme weather events today to climate change. So, for example, I don't know if you all remember the heat wave in the Pacific Northwest in 2021 out in Portland and so forth. There are studies, attribution studies that have been conducted that suggest that the magnitude of that heat wave was 150 times more likely because of climate change. And so we do have skill in the attribution space to kind of link. But one of the things that is a challenge, and I see it with farmers in our state, a farmer really knows what's going on his or her farm. And so even when you talk to a person, they may recognize that there's been more variability in the intensity of drought at their farm. And sometimes they don't make the broader link. The whole sort of saying everything's local. And so there is a nuance in terms of how you talk about that global scale process and how it downscales to that farm.
Well, so one last question on the science front, which is about machine learning.
Mm-hmm.
So you can model and you can try to do a perfect model, which is, we know, is very hard for a complex system.
It'll never be
So
perfect.
So
Sure.
how is machine learning helping us to do this?
Yeah, you asked that same question as well. We had a nice conversation over here.
Yeah.
Machine learning and artificial intelligence are really one of the next great frontiers in meteorology, because of sort of, in some ways, some people have used sort of machine learning concepts in this field for some time, looking at analogs and patterns and gathering large volumes of data to extract the signal from them. That's, even my master's thesis back in the early 90s used a genetic algorithm to try to extract signal in random radar patterns that could then be identified as a landfalling hurricane. And so I think in some ways our field has already been on the forefront of some of these AI machine learning techniques. But if you look at some of the things that even some of our private sector companies like IBM, by the way, the federal government, National Weather Service, NOAA, they are the best. But one of the things that's happening in our field is there is a proliferation of private entities that are now in this space, the IBM, Panasonic, and others, and even smaller companies that are pushing forward on some of these high-end techniques for predictability.
Yeah, that's great. So I'm going to turn to some humanistic questions, but before I do that, I wanted to thank two people, Michelle Strobel, who's somewhere here, who did a lot of work, and Anna Loyanica, who's sitting right there. And the one, right, but there's a question that Anna has because she's getting married next Friday. Is it going to rain next Friday?
I don't know. I have to look.
Good
Let
answer.
me pull up my app.
Okay, so I want to come back to the sort of humanistic side, which I've always thought a lot about, but this idea of mass migration and how climate, this is more climate change and weather, but of course it's the influence of weather locally
Sure.
that causes people for famine, basically droughts. First of all, how do you quantify that? Can you actually connect? Can you correlate the kinds of things we're seeing now, right? Whether it comes out of Africa to Europe, whether it comes from the southern hemisphere to the northern. How do you make that connection, and can you?
Yeah, so one of the frontiers in weather and climate is sort of the merger of physical science with social sciences, things like sociology and demography and so forth. One of our former students at the University of Georgia, he's now at Florida State University in the sociology department. He is an expert on migration within the US. And one of the things that his name's Dr. Matt Howard, one of the things he's been studying is how changes in the sea level rise and the intensity of hurricanes in the coast are going to lead to people in some of these coastal cities migrating inland to cities. And what are those receptor cities? And we saw an example of that with Hurricane Katrina in 2005. After Hurricane Katrina, Atlanta, Nashville, and Memphis became receptor cities. Now that's on a national scale. We're already seeing climate refugees and climate migration globally. There are some people's islands that just won't be there and maybe aren't there. Even with Hurricane Maria in Puerto Rico, there were people in Puerto Rico, fellow US citizens, who were without power for months. And so many of them just left. And so you're going to see that. Now, on the national security side of the house, our national military and other agencies are thinking about this too, because as you can't grow certain things in parts of Africa and other parts of Asia, guess what? These people need to eat, so they're going to move somewhere else. And so then that could possibly create conflict and destabilize governments due to immigration issues and so forth. So there's a complex narrative there that very much is what I talked about with these wicked challenges.
So this sort of leads to the question again, coming back to changing people's opinions. When you see your neighbors, you see, people in Florida having to move out of the Everglades or wherever they live because of this kind of thing. That has an influence. But what would you recommend to help us, beyond the marinade is good to understand what's going on, but the how to move people's minds, and seeing this kind of mass migration or it could have an effect. But in the US in particular, there are a lot of people who seem to either not pay attention or, how do we help you?
It's partly our fault. It's partly our fault as a scholarly community, because for too long people see climate and climate changes about polar bears in the year 2080 and not about Cheerios. And what I mean by that is that when there's significant drought in the Midwest, they're paying more for Cheerios or popcorn. And so I often talk about this notion of the kitchen table issues. Most people aren't ever going to think about this from the lens that I think about it. They're not. But they understand the price of cereal, or they understand the price of gasoline spiking when hurricanes are barreling through the Gulf of Mexico and oil rigs are being evacuated. So basic law of supply and demand, you're reducing supply. Or they understand that a mosquito now lives in Orlando, Florida, that can carry a disease. And that mosquito 20 years ago could not live in Orlando, Florida. It was in Costa Rica somewhere. So as we see these envelopes migrating poleward, it starts to have an impact on their kids. So the more we can bring these discussions to kitchen table issues for people, I think we can move the needle. And I think we are moving the needle. I think there has been a discourse shift in this country, and the data bears it out. So I don't think we are where we were 10 years ago or 20 years ago. I don't deal with nearly as much it's not real, or it's a hoax, or y'all said there was going to be an ice age because Time magazine said so in 1973 or whatever. I think we've moved a little bit beyond that. We are in what's called a climate delayism phase right now. I was at the White House Forum on that last year. This idea that we now have moved beyond this debate about whether it's happening, but now the debate is centered around how much it's going to cost.
So to that point, then there's another, I think it's tongue in cheek, but I'll apologize. It's not. Basically, you're talking about moving people's minds at their kitchen table, right? But also our politics plays a big role in this, right? Where money's invested, whether it's for weather research or whether it's for actually, putting up barriers against, or deciding on carbon emissions, et cetera. So one question is, which approach would ensure success? This is very dichotomous. Increased funding for lobbyists or increased funding for publicists? Where would you go? This is like
I would not go in any of those. I just want to make sure we ensure that we have robust funding for science. But I'm not the scientist who just sits there and says we need more funding, because no scientist is not going to say that. I think we need sort of a multifaceted, in the same way I talked about these complex problems. We have to also understand how the science that we're funding is interacting with marginalized communities, disenfranchised populations. We have to make sure that the technology that is there is not being developed on the backs of others as well. So I think there's got to be more sort of interdisciplinarity in our policy making. Again, I'll give you an example. This infrastructure bill that was just passed, great bill. It's a lot of climate stuff in it. But I talk to people in Georgia and communities, local stakeholders and so forth. They have no idea how to get access to it. I mean, have you seen what it takes to get access to this amount of money that's out there? So we've got to simplify that process.
All right, I think we're running out of time. Oh, one more question? Okay. Well, there's a lot of good questions here, and I apologize to those who we couldn't answer all the questions. Maybe come back to what you started at the beginning. I think there's still an interest in understanding the difference between weather.
Oh, sure. Yeah, I never got to that. So
come to that, because I think that would be important for us to leave with that idea.
So, by the way, I don't think you guys had any snow here. Did you have any snow here in DC this year? I don't think you did. Yeah. So I listened to this radio show here, sports talk radio show here in the area called the Sports Junkie sometimes. And they were just talking this morning about how there's this infestation of rats and rodents here in DC. And apparently it's increased here in the city quite a bit. And one of the reasons is they go away when it's cold. You didn't really have much cold, snowy weather here. But I have this little analogy that I use when someone tweets me from Boston in January and says, "Hey, Dr. Shepard, I got 20 inches of global warming in my yard. What are you guys talking about?" So I was like, it's a cute tweet. It definitely makes me chuckle as well. But it really illustrates that person doesn't understand the difference between weather and climate. And so I often say weather is your mood and climate is your personality, because your mood today doesn't tell me anything about your personality any more than one day or 1 week's weather tells me about climate. And so what I really should say to that person is, it's January, it's Boston, it snows. Because there is this perception somehow that as climate warms, we won't have winter anymore. And that's governed by the orbital mechanics of the planet and the sun. So again, it just comes down to some of those perception challenges.
Thank you. So please join me in giving Professor Shepard a big round of applause.
Thank you all for coming.
And I know there are plenty of places you can, for further, if you want to hear him speak more, which I certainly will, Professor Shepard is all over YouTube, and you can find lots of places where he makes these important points in different ways, in different directions, triangles, circles,
yes,
whatever. So thank you very much for joining us.
Thank you so much. Thank you all for coming.
A tree, and I feel like I'm clinging to a cloud I can't understand. I get misty just holding your hand.